Dear viewers, today I am going to show the instantaneous war compensator STATCOM developed by National-Infotech. So in this part we will see the performance of this STATCOM and closed loop mode. So at the previous part I already discussed about the connections and everything. So now just you can turn on the control supply, and by pressing this button you can just go to the closed loop mode. Okay, and first of all we will see the performance in the RL load. So MCB turn on, load MCB, you can turn on it. Now switch 1 is on, means R1 is on, and the load RL load is there. So L we have connected in series, so RL load we have connected. Okay, now just by pressing this button you can just turn on the supply. Okay, just turn on the supply by pressing this button, and you can just see the performance. Okay, so now you can see the IQL is minus 0.4. so my ID and IQ and IQR is 0.4. okay, so it is already compensate the power factor 0.99. okay, and ID is 0 and VDC is regulated to 200 volt. okay, and here we have in the closed loop we have see the different DEC values. okay, now you can just see the current. okay, so now you can just see the load is the RL load. okay, load is the RL load, so my current is now at leading. okay, just you can see the voltage is yellow one and the current is the blue one, so it is the leading current are there. okay, and also you can just see the power factor, so the power factor is 0.99 is maintained. okay, now I am increasing in the closed loop mode RL load, I am increasing the current capacity. so now you can just see I am increasing the current. okay, so my IQ is now increased to 1.2 1.3. okay, and my IQL is minus 1.3 and ID is 0 and VDC is regulated to 200 volt. and also you can just see the voltage and current, so current is leading. okay, and also you can just see the power factor is compensated and maintain the unity power factor. and also you can just see the performance KVAR 0, KVA 0.0, also KW 0, current is 1 minus 1.6, and line to line voltage and phase voltage. okay, so you can just see the different parameters in this power factor meter. okay, also you can just see the voltage and current. okay, so likewise this you can observe the voltage and current. okay, and now turn off the control. now we will perform this practical with the RC in the closed loop mode. so first you can turn off this and toggle this switch to RC. okay, and now you can just see the power factor. so you can just see the power factor is minus 0.95. it is leading power factor, poor leading power factor. okay, 0.95. okay, now we will turn on the control and see the performance. okay, now you can just by pressing this left button you can just turn on the control. so IQL is 0.5, ID is 0, so my IQ and IQR is also 0, VDC is 200 volt, different DEC values are also there. okay, so IQ and IQR is minus 0.5. okay, and also you can just see my load is RC load, so the current is now lag. okay, from the voltage reference, and also you can just see the power factor is 0.99. okay, now I am increasing the load. And see the performance. Though IQL is 1.4, VDC is also regulated 200 volt. okay, different DEC values are here. okay, and IQ and IQR compensation current is minus 1.4. okay, and here you can just see the current, voltage and current. okay, and also you can see the power factor is maintained at 0.99. okay, So unity power factor is maintained here also, and in the capacitive you can just see kVA, var 0, kVA, kW, current, voltage, okay, and line voltage and phase voltage. So likewise this you can measure different values. Okay, now we will see the voltage and current at the source side and see the performance. Okay, so now I have connected the DSO at the source side and we will see the unity power factor. Okay, so voltage and current are in phase, so here we can measure. So you can just see the voltage and current waveform with RC load. Okay, so you can just see the voltage and current are in phase, the power factor is 0.99, so that the voltage and current are in phase. Now I am decreasing the load. Okay, then you can just see it is compensated fastly, it is compensated. Okay, voltage and current are in phase again. Okay, you can just verify it. Okay, you can just see. Okay, and also you can observe the current on the DSO, sorry, on the clamp on meter. So you can just see the current is 1 ampere, 1 ampere, 1.1, 1 ampere. Okay, now I am increasing the load. So this waveform is for the RC. Okay, so the current is now 1.7, 1.7 and the 1.7. so balance current are also there. Okay, and you can just see the power factor 0.99, it is maintained. Okay, now we will see the performance in the RL load. So turn off it first, then reduce the load. Okay, just you can just see the voltage and current here also. Okay, so now toggle to RL. Okay, one load is there, closed loop mode are there, and just you can turn on it. Okay, so you can just see it is try to compensate. Okay, at unity power factor, and also you can see the voltage and current waveform. Okay, also you can see the IQ and IR, IL, IQL like that. Okay, now I am increasing the load. Okay, so current is now increasing, voltage is maintained. Okay, IQ R 1.3, 1.3, IQL is also minus 1.3 and ID is 0. Also you can just see the waveform, the voltage and current, it is almost unity, and here you can see the power factor is unity. Okay, now we will see the different DAC values in the RL load or RC load, whatever load you have. You can just observe the different DAC values. That means the control signals we can observe from the DAC. Okay, so we will see. So now I have connected the DAC here, and we will see the different DAC values. So first of all you can just select the DAC value. So by pressing this button you can just select the DAC first. Okay, then you can increase or decrease the DAC values. Okay, so here is the current IL, VA for the phase channel 1 and IA for the channel 2. Okay, so now I am changing. Okay, so it is angle. Okay, it is decreasing by pressing this DAC value is decrease. Okay, and by pressing this DAC value is increase. Okay, so this is the IA. IB, IC, ILA, okay, sorry, ILA, I alpha, like this, okay. So VA command, VB command, VC command, okay. And also you can just, by pressing this button, you can just decrease the DAC values, and you can observe the different DAC. Okay, so likewise this, you can also see that different DAC values, means the control signal from the controller. So likewise this, you can perform the practical of the STATCOM in the open loop mode and the closed loop mode with RL and RC load. Thank you.